So if you take a line, definitely two endpoints are, if two endpoints are given to you. So the first point, let us say P1 is the first point, and P2 is the second point. These 2 points would be supplied to you, right? And when 2 points are supplied to you, you know how to find out the equation of a straight line using non-parametric form. All those y minus y1 is equal to x2 minus x1 by different equations are there, right? All those equations can help you to derive the equation in non-parametric form. All such kind of forms come under non-parametric form, but non-parametric, as I explained a lot, non-parametric representation has a lot of limitations. So that is the reason we are moving towards the parametric form. So in parametric form, how a line would be defined. So the first point, let us say P1, second point, let us say P2. So almost in all the cases, at first point we are introducing a new variable called u. Considering u value is 0 at the first point, and u value varies from 0 to 1 in between, and the maximum value of u is 1. So in that case, any point, let us say any point P would be represented like P1 plus U into P2 minus P1. This is how, this is the parametric representation of a straight line, provided the endpoints are given to you. P1 is first point and P2 is the second. In that case, that is how the equation would be represented. And as I told you, all the parametric equations do come with a new parameter, limits of a new parameter called u, right? So u is varying from 0 to 1. Now the same equation, can also be elaborated, like x is equal to, this is the scalar form of the same equation. This is a parametric form. This is called a scalar form or algebraic form. Okay, in different textbooks they use different words. So for the same thing, how it will be explained, like the P means it is actually representing point, right? P means it is representing point. Point means it does have all the three coordinates: x coordinate, y coordinate, z coordinate. So each coordinate you should be in a position to calculate, right? So x coordinate, how you can calculate? Instead of P1, use x1. X1 means x coordinate of the first point, and u is the equation form is same. Only thing is instead of P, x would be supplied, and similarly y coordinate can be calculated in from this, and z coordinate can be calculated from this equation. That is how x, y, z coordinates would be calculated. What do you mean by this? Let us say generate a straight line, which are passing from 1 to comma 3 4. Let us say you want to generate a straight line, or you want to derive the equation which are whose starting point is 1 2, ending point is 3 4, considering only xy plane. Let us say I'm considering the point, or if you want you can take another coordinate also, no problem. 1 2 5, let us say 1 2 5 3 4 6. Let us say in space you want to, it's the line is lying in space. You can do that. So how do you do that? This is the basic parametric representation, and then x, how the x equation will become x is equal to, x1 means 1, right? 1 plus u will be, it's a variable actually, u multiplied by x2 minus x1. x2 minus x1 means the x2 is 3, x1 is 1. 3 minus 1 2. So what do you mean by this? X is equal to x, you can get the equation like x is equal to 2u plus 1. This is the equation. Similarly, you get y equation and z equation also. Every equation you will get it in terms of u. So then how do you derive all the points on the straight line? It's very simple, right? It's very simple. This is the database to get all the points on the straight line. So first variable would be u, and then x, y, z. Why? Because u is the actual variable. So u is varying from 0 and till 1. In between, it is up to you how many how many intervals you want. If you want more number of points on the straight line, then you have to keep the interval small. If you want less number of points, like let us say you just want to show the straight line with only 10 number of points, 10 number of points, then you have to get the interval also in the so how can you calculate the interval? It is very simple. Let us say you are representing the interval value as delta u, which is the interval value. If you want to know delta u, let us say you want to get 10 points on the 10 points on the straight line, then u maximum minus u minimum, delta u is equal to, I'm trying to calculate the interval. Okay, so u maximum is 1 minus u minimum is 0 divided by number of points. How many number of points I want? N, right? So that 10, right? 10 minus 1, that will be 9. So 1 by 9, that would be the interval which you need to calculate, and probably you get some value 0.11 or something, right? So 0.11 and then 0.22, every interval would be 0. Let us say if this 1 by 9 value is, if it is approximately equal to 0.11, then that is how the u values will vary from one point to another point, and substitute these u values in these xyz equations, so that the corresponding, if you substitute u in this, obviously you will get 1 to 5 only. Similarly, if you substitute one value in these xyz equations, obviously you get the 3 4 6 for xyz coordinates. So like that, in between also you can get all the various points corresponding to every u value starting from 0 to 1, and all these points, if you try to display, you will get it 10 number of points on the straight line, and which looks like a straight line. Okay, but if you see that if you feel like the points are not sufficient, and you want more coarse or number of points so that it exactly looks like a straight line, then obviously the delta u value must also be reduced a lot. So instead of 10 number of points, you can think of some 100 points or 101 points. So if you say 101 points, obviously the number of divisions of the straight line would be 101 minus 100 divisions, right? So which would be easy. So that is how you can you can solve any straight line using parametric representation. And now coming to the unit vector n bar in the direction of the straight line, you know all these vector calculations. So unit vector, given any two endpoints, unit vector p2 minus p1 by L, where L is the modulus of p2 minus p1, which you can calculate from this, which is nothing but the length of the straight line, right? So similarly, circles and arcs, how circles and arcs would be represented. If I am already, I already told you, the circle, the parametric representation of a circle would be x is equal to x c r cos theta, where xc is the center of the circle. Okay, if the center of the circle is provided to you, then this is the equation. If the origin is the center, then simple equations are r cos theta, r sin theta, right? So instead of theta, here it is represented like u value, or else you can even write theta also. No problem. As long as you are using one variable, that is good enough for curves, any type of curves, right? So, and here being it is a angular for circle, that particular angle u varies from 0 to 2 pi. Okay. Similarly, in case of a arc means part of a circle. Only difference is you can still use the same equations. Only difference is the u value will have a certain minimum value and a maximum value. Okay, us is nothing but the minimum or starting value. ue is nothing but the end value. Okay, so if you vary from u is equal to 90 degree or pi by 2 to pi, then obviously I get this part of the circle, which I can treat it like an arc, right? So by simply varying a u value, uh, I can get a arc also. So that is the advantage of parametric representation. Why? Because the same equation, the set of equations are same. The same set of equations I can use it for different entities, right? Now, coming to the conic sections, you all know the equations. Okay, when a HK has a center or vertex, the in case of ellipse you call it as a center. In case of a parabola and a hyperbola, you call it as a vertex, right? So you know all the equations. If provided if the HK point is also given to you, the basic equation probably you would have learned, you would have remembered, like x square by a square plus y square by b square. That is the basic ellipse equation whose center is 0 0 origin. But if the center is something different, then the equations consists of minus h minus k, like this. Similarly, parabola equation, you can have three different forms of parabolic equation and also hyperbola, this kind of form. Now this is a non-parametric way of representing. These equations will not help us, cannot help us in solving the problem, and also to play with the curve. Whereas in case of parametric representation, the same ellipse, it would be x would be like this. X is where is xc is the center, yc xc and comma yc is the center of the ellipse, right? Xc plus a cos u. A is the some coefficient. B is another coefficient. They are constant values. Okay, they are some constant values. They are not variables. This is the only variable. Okay, so for different constants or coefficient values, the ellipse equation also would be different, right? So this is how it will be represented. And so wait, and similarly for parabola, look at it here, u is varying from 0 to 2 pi, being its ellipse. Whereas for parabola and hyperbola, even for hyperbola also, u varies from 0 to infinity. Okay, here also the same kind of limits. U is varying from 0 to infinity. So it is up to you how many u values you want to use it, depending upon how much geometry you want to play with. Yes. Okay, I'm back. You can remember all these the parametric equations or representations of different conic sections. Okay, and with this I am concluding the